Theoretical recap. In Python, a list is an ordered, mutable collection of items defined with square brackets. My_list equals 80, 443, 22, 8080. Lists are one of the most fundamental data structures you will use in security automation. For example, storing a set of ports to scan, a range of IP addresses, or a collection of known vulnerabilities. You iterate over a list using a for loop, for item in my_list. You can also build lists dynamically using list or the range function. For example, list range 1, 1025, generates all ports from 1 to 1024. A common mistake at this stage is confusing range, which produces a range object, with an actual list. Always remember that range 1, 10, does not print as a list unless you explicitly convert it. Another frequent pitfall is off by 1 errors. Range 1, 1025, includes 1 but stops at 1024, exactly what you want for well-known ports. In a cybersecurity context, iterating over a port list is the conceptual foundation of a port scanner. Before you can build anything more complex, using subprocess, sockets, or Nmap wrappers, you need to master constructing and traversing port lists programmatically. This workshop bridges your knowledge of data structures and the subprocess/OS scripting work you did in previous sessions. Mini example. Python. Ports equals 21, 22, 80, 443, 8080 for port imports. Printf checking port. Workshop brief. This workshop puts into practice your understanding of Python lists, loops, and basic scripting. You will write a Python script that builds a list of ports, iterates over it, and performs a basic action for each port. This is a hands-on exercise designed to solidify your ability to work with data structures in a security automation context, a skill you will rely on throughout the rest of this course when building scanners and automation tools. Step 1. Build your port list. Start by creating a Python script called port_scanner_base.py. In this script, define at least 2 separate lists of ports. One manually constructed list containing a selection of well-known ports, for example, FTP, SSH, HTTP, HTTPS, SMB, RDP, DNS, choose at least 10, and one dynamically generated list using range covering all ports from 1 to 1024. Store both in clearly named variables. Think carefully about the difference between hard-coding values and generating them programmatically. When would each approach be preferable in a real security context? Step 2. Iterate and display. Write a for loop that iterates over your manually defined list and prints each port number with a descriptive label. For example, port 22, SSH. Create a dictionary that maps port numbers to their associated service names, and use it inside your loop to display the service name next to the port number. This will reinforce your use of both lists and dictionaries together, as covered in the previous lesson on data structures. Step 3. Filter and select. Add logic to your script that filters the dynamically generated port list, 1 to 1024, to extract only the ports that are also present in your manually defined list. Print the resulting filtered list. Then, separately, iterate over the full 1 to 1024 range and print only ports that are multiples of 100. This exercises your ability to add conditional logic inside loops. Step 4. Integrate subprocess. For each port in your manually defined list, use the subprocess library, which you worked with in previous workshops, to attempt a basic connectivity check or simply log a message simulating what a scanner would do. You are not required to implement a real socket connection at this stage. The goal is to demonstrate that you can combine list iteration with subprocess calls or print-based simulation in a structured script. If you feel confident, attempt a real TCP connection check using Python's socket module as a bonus. Step 5. Output and documentation. Save the results of your iteration to a text file called port_scan_results.txt. Each line should contain the port number, the service name, from your dictionary, and a status message. Add a docstring to your script and comments explaining each major section, following the documentation practices covered in the earlier lesson on docstrings. Make sure your script runs without errors from the command line using Python port_scanner_base.py. Take time to reflect on your choices. Why did you select those specific ports for your manual list? What are the advantages of using range versus a hard-coded list in a real-world scanner? Note your answers as comments in the script. This analytical reflection is part of the evaluation. You have 2 hours to complete this workshop. Submit your solution before the deadline expires. Late submissions will not be accepted.